In this video, we show the practices that support ongoing changes in student thinking. This video continues from a previous lesson in which Anna has taken up the idea of heat with her students, then engaged them in an investigation in which they tested how heat moves through matter. Midway through the lesson we show here, Anna is not convinced that her students understand how heat behaves at the molecular level. She introduces a sense-making activity that she refers to as science theater.
So, where are these heat molecules coming from? The flame, okay. And then, if you had to draw them, what would they look like compared to the metal molecules?
And more space.
Okay. Our next person is Daniel. Daniel, what did you write?
That the molecules move back and forth through the metal.
Okay. And what happens when we put that metal over a flame? What happens to the molecules?
That the molecules are moving all around the places, they're moving all around the metal.
Okay. And if a bunch of molecules in the metal at the very end start moving faster, does that do anything to the other molecules in the metal?
It makes no, it makes them they just keep moving a little faster.
So they keep moving the same speed, or they move a little faster?
They'll move a little faster.
So it does change something?
Yeah.
Okay.
I said, so when the flame touches the metal, all the molecules on the solid of the metal, they retract that heat, and the first molecule pushes it onto the second one, and all those molecules push it on until it gets the end, until the flame goes out. And I said I can relate it to like putting line dominoes up in front of each other and then knock the first one down. And they all knock down after you push the first one until the flame goes out and until the dominoes end.
Okay. So, Delbert, can you connect your idea of molecules interacting with molecules to what Alana just said?
Yeah.
Try. How is it related? Maybe using the domino example? Okay, so if one molecule touches another molecule, then what happens? Well, think about the domino example. What happens for dominoes?
One takes the other and the other one falls.
And then,
The next one.
so it happens one by one, right?
Yeah.
So do you think that Alana is onto something with this analogy, that that's exactly the same thing that's happening with the molecules? That makes sense to you? Okay. Or maybe explain what's similar about your ideas.
It's more familiar because he was talking about the dominoes, how there's a bunch of dominoes, and then how you push the first one, they knock it down, and then until he said until the flame goes out, they all fall down and the flame goes out, and what I said was how the molecules are moving faster, and how you asked me a question how the flame, if we put it more, how they changes mostly the speed of the molecules.
The molecules were moving fast and had lots of space in between, and the molecules reached up the metal by the flame pushing the molecules up.
So the space part.
Okay.
Yeah, so Alano, you've done dominoes before, right?
Yeah.
So can you tell everybody, like, when you stack up the dominoes, can you tell them about how you do it?
Like you stack one in front of the other until you're all out of dominoes.
But are the dominoes touching each other?
No,
Why not?
they have space so they can knock each other down.
What I need everybody to do is leave all of your things at your desk. You're going to stand up, and we're going to go to the back idea space area. Okay? So you're going to be standing pretty close to other people. Okay? But I just want you to stand there silently and wait for my next direction. All right. You are no longer human beings. You are molecules.
Yay! No.
Okay, so we are going to now on because I now need to come back here and wait for my next direction. So what I would like you to do, as a class, you're going to have to work together. You need to arrange yourselves how you think the molecules in that metal piece look. Were the molecules of metal, are they different sizes?
Yes.
Yeah.
No.
No. So the height doesn't matter. Alright? So what I would like you to do is think about the spacing, the arrangement, and the movement of the molecules in that metal piece before it's heated. And I want you to arrange like that.
But this is metal, we don't move that much, right?
Yeah, but they're
Just like that.
So get everyone involved, every single person.
Just line up here, what are these for? Line up here.
Okay, I need a volunteer to raise their hand and tell me why this is the correct arrangement to imitate the molecules in the metal piece. Okay? So we're going to start from this side and swing this way along.
Because in the solid, usually molecules are all bunched up together and barely moving.
Okay? You guys are definitely all moving. I see lots of fidgeting happening. Okay? Trump?
They're still in rows.
You're in rows. Okay. Elizabeth, did you have your hand up? No? Anybody else? No. Was it Alicia? Did you have your hand up? So what is another reason why this is the right way to model molecules in that metal piece? Curtis and Alex.
Because everybody's close together and we're still moving a little bit in their space.
Okay. Alright. So there is a little bit of, you guys aren't packed in next to each other, are you? So gentlemen, you shouldn't be smacked up next. Yep. Okay. Alright, so now what we're going to do is we're going to see what happens when we heat one end of this. So, Malia, could you be our candle? Are you sure? All you have to do is stand there. Okay, so Malia's our candle. Okay, so this is the end of the metal. You definitely should still be moving, because we just said that molecules move. So you're okay to move, but you need to be silent. Okay? So I want to know what's going to happen when we light the candle on this end. And I want you guys to try to model what that's happening and explain. Malia is a candle. Okay? So Bless, I think you need to step out and maybe tell people what to do.
Yeah. These guys over here will get crazy and then start getting crazy with me and then it'll get crazy over there too.
Maybe you'll get them to start doing it and see if they're doing what you want them to do.
Stop moving
Alright?
Hold yourself.
Remember, you have to be safe. Okay, now pause. Everybody freeze. Freeze. The only thing I want you to do right now is move as much as you think a heated metal molecule would move. Now I need everybody to pause. Alano, you wanted to add something? Do you think that was a good demonstration, or is there something you would add to what Bless had them do? Yeah? You can.
Well, first let's hear from, let's hear from Les first.
Okay.
Before Alano adds on, you said that you wanted to sort of divide it into thirds, right? So the first third would go crazy, the second third would go crazy, the third third would go crazy. Why was that the way you wanted it done?
Because when the fire is heating this side, and when the fire starts going, make them close.
So what makes the molecules go crazy? Like
The heat.
where Deja is here, what makes her area start to go crazy? But the fire isn't close to her.
It's these guys because they're hot.
us and
Heat.
So don't say they're hot. Tell me how they're moving.
They're moving fast, and then it's making them.
Hot.
Yeah, 'cause they're hot, and then
So explain to me how tin moving fast makes Deja move fast. Because they're not standing next to each other.
passing on like.
Wait. Okay. Bro, do you think you can explain what Bless means by passing heat?
Because heat goes to other molecules which pass it on. Like he passes it on to food, then he passes on to Daniel, and
How?
he keeps going to everyone.
How does tin pass heat to the molecules next to it? Tin, how do you
Bump to other molecules.
You did what?
Bump to other molecules.
You did what? Say it loud.
I bumped to other molecules.
Oh, so when you bump into Fook, what happens?
Everyone.
And then he's all
All right, bring it back, guys. Tin, what happens when you bump into Fook? What do you mean? Tell me. You bumped into who?
Daniel.
Daniel, and who did Daniel bump into? Maybe Victor, and maybe who did Victor bump into?
Herbert
Or Deja, right? So that explains how you get to Deja. Cool.
But so Daniel, if you're moving around, like after you get bumped, you're kind of in the middle, right? When you move, do the people over here feel you moving?
No,
Why not?
because they won't be over there, and I won't be in the middle. Because like the people in front of me and back of me.
Oh, say that again. This is important.
Yeah, you guys need to listen.
Say that again.
Yeah, I'm in the middle, and I'm mostly bumping everybody in front of me, and back up in the back and back of me.
And you're not bumping the people over here?
I'm like moving front, back, and like side to side.
So you're only bumping the people where?
That are
Close to you, or are they?
around me.
Okay.
Around me, and they're like bumping other people. They're like,
Hey! Pay attention. Two people in the middle as a toothpicks, and then like 2 people surrounding that. Those 2 people, like 6 people, and 3 people are surrounding 1 toothpick, and then the other 3 surrounding the other. So when the heat touches the wax, it starts melting, and then it's like one of the first 2 people will probably sit down at the toothpick.
Are you gonna try and model the whole thing? Yes.
Wax.
The what? All right. So we have our toothpicks, we have our wax, and then what do we need everybody else
No,
to
you
do?
got molecules, or you need the molecules to surround the wax and all that.
So it's gonna touch me, I'm gonna touch her, I'm gonna pass it on without having to bump into everybody else.
And
And
the
then I,
metal molecules, you gotta make sure you guys on the center of the back, the wax molecules, because they gotta,
so you have
burn things though.
Good job.
Good God, I saw it.
Hey,
Curtis!
drop. What? Oh, drop.
that was like.
So our question is, when the candle was lit, when Malia first said go, why weren't these people moving faster? These molecules moving faster at the far end of the metal stick.
Because they weren't close to the fire, which was actually touching other molecules that were near each other. So they had to go a while longer for it to like touch them so they can start, but it wasn't there yet, so they had to like wait for like every 7 minutes. That's why the last go was 1 minute and not like 10 seconds like the first 2 things. So
I know Raul used the words passing heat, but what's the only way for you as a molecule close to the flame to pass heat to me, a molecule at the other end of the stick?
touching other molecules.
By what?
Touching the other molecules and
Which other molecule?
the one like around me and then just pass it to the other one.
The ones that are like already moving, and like there's like new ones like coming, like the other ones that are like already going like a little faster than the other ones. They bump in into the other ones, and they change the speed of the other ones. So then they make more. So then they make the. So then they can make more. So they can make the molecules move faster.
When molecules get hot, they spread out. So when the molecules got hot, they touch other molecules. Touch other molecules, and the molecules started going faster, and they spread it out more. So when the molecule that was hot touched the molecule that wasn't, they changed the speed of the molecule that wasn't. So that's how it got so hot.
So what I'd like you to do is open your journal to your entry from that you started yesterday. This should be on page 24. So I'd like you to try to put together everything that we've just been talking about and showing. I want you to remember, it's very important to record your ideas. So right now, I want us to document everything that's in our brains right now so that we don't lose it. So your sentence starter is, heat is transferred by. And I've given you some words that I'd like you to try to use. One is molecule or molecules, speed, hit, collide, movement, maybe space. You don't have to use these words. This is more of an idea checklist. So what can you tell me about the molecules and their speed and the space between them, how they interact, how they're moving?
As we close out this lesson, we see that Anna has taken a risk by engaging her students in this physical activity. It turns out that her students will reference this experience repeatedly in upcoming lessons as a touchstone for how they think now about heat and molecular movement.